Hi, this is Joe from the Math Perimeter, where I help to make mathematics accessible, engaging, and approachable through videos, articles, and infographics. In this video, you will learn how to use a couple of tricks that occasionally come up when integrating by parts. For more information about this topic, please refer to the article linked in the description. In this video, we will use integration by parts to evaluate the integral of e to the x sine of x dx and the integral of ln of x minus 1 all over ln squared of x dx. We begin by computing the integral of e to the x sine of x dx. We begin by setting I equals the integral of e to the x sine of x dx. Now we integrate by parts. We start by choosing u equals sine of x and dv equals e to the x dx, then du equals cosine of x dx and v equals e to the x. Applying the integration by parts formula, we obtain I equals e to the x sine of x minus the integral of e to the x cosine of x dx. We now integrate by parts again. This time choose u equals negative cosine of x and dv equals e to the x dx, then du equals sine of x dx and v equals e to the x. Applying the integration by parts formula then gives I equals e to the x sine of x minus e to the x cosine of x minus the integral of e to the x sine of x dx. The remaining integral is I, so we have I equals e to the x sine of x minus e to the x cosine of x minus I. Adding I to both sides of the equation then gives 2I equals e to the x sine of x minus e to the x cosine of x plus c. Dividing both sides of the equation by 2, we arrive at a final answer of I equals 1/2 e to the x sine of x minus 1/2 e to the x cosine of x plus c. Next, we evaluate the integral of ln of x minus 1 all over ln squared of x dx. Splitting the fraction, we obtain the integral of ln of x over ln squared of x minus 1 over ln squared of x dx. Simplifying then gives the integral of 1 over ln of x minus 1 over ln squared of x dx. Using the sum rule, we obtain the integral of 1 over ln of x dx minus the integral of 1 over ln squared of x dx, multiplying the numerator and denominator of the second integral by x then gives the integral of 1 over ln of x dx minus the integral of x over x ln squared of x dx. We now evaluate the second integral using integration by parts. Choose u equals x and dv equals negative 1 over x ln squared of x dx. Then du equals dx and v equals minus the integral of 1 over x ln squared of x dx. Applying the integration by parts formula then gives the integral of 1 over ln of x dx plus xv minus the integral of v dx. Next, we compute v. To begin, we let u equals ln of x. The differential is then du equals 1 over x dx. Substituting into the integral, we get v equals minus the integral of 1 over u squared du. Rewriting the integrand in terms of negative exponents then gives v equals minus the integral of u to the negative 2 du. Integrating then gives v equals u to the negative 1. In terms of positive exponents, this is v equals 1 over u. Back substituting, we obtain v equals 1 over ln of x. Inserting v back into our original integral then gives the integral of 1 over ln of x dx plus x over ln of x minus the integral of 1 over ln of x dx. Canceling the integrals, we arrive at a final answer of x over ln of x plus c. Thank you for watching. I hope you enjoyed the video. Please like and subscribe. Thank you. See you next time.